all in the next lecture of the functions, and here we will discuss about that how will we define our one and onto function by graphically and mathematically. So now first we talk about the equal functions. What are the equal functions? If we consider our two functions f and g, that is from set A to set B, the two functions f and g are said to be equal. When it is equal, if and only if fa equal to ga for all a belongs to a. So if we have for all elements of a, we have the equality condition of fa equal to fga, so we can say that that function is the equal functions. So we say that two functions f and g are equal if they have the same domain and same codomain, right? Next, unequal function. So what is an unequal function? If there exists at least one element a in set A such that fa not equal to ga, then we can say that f and g are called unequal functions. Means if we have at least one element in the set A, that we can say that for fa not equal to ga, so that is the unequal functions. Next is the identity function. So what is the identity function? Let us consider a set A and a mapping f such that a into a is called the identity function. That is, each element of a is mapped to itself, right? So this is the identity function. Like that, if we have a set domain is this and the codomain is this, because we have the set a into a, so our codomain is a and domain is a and codomain is also a. So now this is the function defined from a to a, and here f1, what is f1? Our 1, f2 is 2, f3 is 3 and f4 is 4. So now this type of function is called the identity function, right? That is our domain, that is our same is the codomain elements, and that is connected to 1 to 1, means so that is called the identity function, right? Next, how can we represent our functions, right, 1 and 2 by graphically? So first is 1. Graphically we can say that a function is 1 if each horizontal line intersects the graph of f in at most one point. So here we have, suppose this is our axis, this is our x-axis, and this is our the y-axis, right? So we say that each horizontal line intersect the graph of f at most one point, means at most one point that will intersect our horizontal line. So here if we have this axis and our graph is supposes like that, this is our graph, right? This is our graph. What is the graph? Is this graph is this y equal to x, right? So now this is 1. Yes, this is 1. Why? Because if you mark any horizontal line like that, here, means if you mark your horizontal line is this and this one, and you write here this, so you can see that each horizontal line here intersect our graph, this y equal to x graph, only at one point, right? So at most one point. So this is our the 1 graph. Next is the onto. So how can we show the onto graph? Onto function. A function is onto if each horizontal line intersect the graph of f at one or more points. Here in 1 condition, at most one point, not the 2, 3 or 4 points that will intersect the graph, but in onto we have the graph f at one or more points. So suppose our graph is like that, you can say is that your graph is, suppose is like that, your graph, right? So here what is that? Here if we draw any horizontal line, suppose here and like that, so here we have that onto function which our horizontal line here intersect the graph at one point here, one point here. So this is the onto function. Clear? Okay, so now let's take an example for this graphical representation. So here we have some functions, so now need to check that it is 1 1 and on 2 by graphically. So suppose first our first graph is that here if we draw a one graph is like that. Suppose I draw a graph that one. So now tell me, this graph is 1 1 and on 2 or not? This is our f1 function and we say that this is neither 1 1 nor on 2. How this is not 1 1? So first we talk about the 1 1. What is the definition of 1 1 by graphically? That our horizontal line intersect the graph at most one point. But here we see that if we draw here the horizontal line like that, so here we have, if we draw the horizontal line is like that, this one, so here this horizontal line intersect our graph at 2 points, right? 2 points, but in the 1 1 condition is that at most one point should be intersect, right? So this is not the 1 1. Now on 2, why it is not on 2? Because in on 2 definition is that the horizontal line cuts the graphs, intersect the graph one or more points. But if we draw the horizontal line here in the our this portion of the graph, so here our horizontal line doesn't intersect our graph at any point. But in the on2 definition we have that the graph must be intersect in or to be on2 that intersect one or more points, right? So this is not the on2 here. Clear? Okay, so now next one is that if our graph is like that, if I draw a graph here, that is 1, so we say that here, so we draw our graph. Suppose our graph is like that, this one is our graph. So what you can say about this graph? This is 1 1 and on 2. This graph is 1 1 but not the on 2. Why is 1 1? Because it satisfies the condition of 1 1 that if we draw the horizontal line, so it must intersect our this graph at only one point, and here not, because the definition is that at most one point. So this is 1 1, but it not fulfill the condition of on 2 function, because these horizontal lines these horizontal lines doesn't intersect our graph at any point, right? Next one is if our graph is suppose like that, if we draw our graph, suppose this is our graph, what you can say about this graph? This is 1 1 and on 2. Yes, this is not the 1 1 but on 2 is there. Why is not 1 1? Because if we draw our horizontal line is like that, so you can see here these horizontal lines are cut our graph at 1 2 3 points. And what is the definition of 1 1? That at most one point if intersect our graph the horizontal line, that is 1 1. So it not fulfill the condition of 1 1. Now come to the point on 2. This is on 2. Yes, because you can draw any horizontal line that will cut our graph at any point. So this is the on 2 function. Next, suppose our graph is like that. If we draw our graph, suppose our graph is this. So now what's to talk about this? This is 1 1 and on 2. Yes, this is 1 1 and on 2 both. Why? Because it fulfills the condition of 1 1 that if we draw any horizontal line, so it cuts our graph at only one point, and 1 on 2 onto that at one point, at least one point, at one point it our horizontal line cuts the graph. So that fulfill the condition of on 2 and 1 1 both. So this type of graph is the 1 1 and on 2 graph, and this graph is not 1 1 but on 2, and this type of graph is our 1 1 not on 2. And if we have this type of graph, so this is our neither 1 1 nor on 2 function. Clear? Now next come to the Now we have method to check that our function is 1 and onto functions by mathematically. So how can we represent by mathematically? We can check our function is 1 and onto. So for this, first we have the 1 function. So a function f a into b is 1 to 1 or 1. What is 1 function? We can say that injective function if for all elements x1 x2 in a such that fx1 equal to fx2, then x1 equal to x2. So what does it mean? Means our images we take, we consider that our images are equal, because in our question we have given the function fx, right, and we need to check that that is 1. So how to do this? First we take that our images are equal, fx1 equal to fx2. When we take fx1 equal to fx2 and after solving we get that x1 equal to x2, so we can say that our function is 1 function. So after this we can say that our function is 1 function, right? Now onto, what is, how to check the onto function? So to check whether y equal to fx from a set a to b is onto or not, write x in terms of y and see if for every y belongs to b, x belongs to a, so we say that it is onto, otherwise not. By practically we say that if we have these two sets a and b, and here we have the elements suppose 1 2 3, and here we have the elements a b c, and this element is connected to this, this connected to this connected to this. So here we have no such elements are there in the codomain which has not the pre-image. So this type of function is the onto function, right? So by practically we can see is like that, but by mathematically how can we show that this is onto function? By mathematically first we put y equal to our fx, because fx is given in the question. So y equal to fx, and then we have to convert our x in terms of y, and we see that because we know that our x is belongs to our a set, right? It means our domain. So then we get the function in y that must be also the belongs to our the set, means codomain. If that is possible, so we say that our function is onto, otherwise not. So now let's take an example about this. Here we have the function f that is n to n, and function fx is given that 2x. So we have to check that this function is 1 or onto. So first 1 we check about the 1. So what was the in 1 condition? We have to put here fx1 equal to fx2. So now if fx1 equal to fx2, what is fx1? Fx1 we have to put here x1, so it is 2x1 equal to 2x2. Now from this we get x1 equal to x2. So now we consider fx1 equal to fx2 and we get that x1 equal to x2. So we say that our function here, our function is the 1 function, right? So our function is the 1 function. Now next is onto. So how to prove that onto function? So we take that y equal to fx. By practically we can see that first here, if we by practically we see that suppose we have the elements are here 1 2 3 4 5 6. So what will be the image here? Your fx is our image, right? And fx is given that 2x. So here we have the set is natural number to natural number. So this is the natural number set, this is the natural number set. So here we have the also the elements are 1 2 3 4 5 6, right? So now if we fulfill our this condition, our fx elements are 2x. So f1, what is our f1? If we put here x equal to 1, then we will get 2. So our fx1 is 2. If we put here x equal to 2, so we get here 4. So f2 is our 4, f3 is our 6, right? So like that we can see that here we have such type of elements are there which has not pre-images, right? So according to this we can say that our function is not onto function, right? So but how to do how can you show this by the mathematically? So you can show it by mathematically is like that. First we put here y equal to fx. So now what is our fx? Fx is 2x, so y equal to 2x. Now put our x in terms of y, so that is x equal to y by 2. So now you can see here, if our x is belongs to natural number, right? We know that our x belongs to the natural number, and we see here we get y by 2. So because the set is a natural number to natural number, so y by 2 is belongs to n natural number. No, because natural number set is 1 2 3 4 5 6, like that we have the whole numbers, but this is y by 2. So this y by 2 I think doesn't belongs to our the natural number. So also you can see that, suppose let's take an example. Suppose we say that our function fx, if here we put f1 by 2, if we put our x equal to 1 by 2 here, so that is what will we get here? That is, if we put here 2 and this is our 1 by 2, so we get our 1, right? But our 1 by 2, it doesn't belongs to the natural number, right? And we say that our function is natural number to natural number, so our 1 by 2 doesn't belongs to the natural number, so we can say that our function f is not onto, right? So our function is not the onto function. Clear? Next, if we take the another example for this, and that is, check the function f such that r to r, and function fx is given 1 by x. So this is 1 1 and onto. We have to check that this is 1 1 or onto. So first we check 1 1. So let fx1 equal to fx2. So fx1 equal to fx2, and our fx is 1 by x, so it become 1 by x1 equal to 1 by x2. And after that we see that x1 equal to x2, so we can say that our function is 1 1. So after this we write that f is 1 1, right? F is 1 1. Now next is check the onto. So for onto function we check here y equal to fx, so put here y equal to fx. So now what is that? Y equal to fx and y equal to 1 by x. So x in terms of y, that is 1 by y, and this set is real to real, so our x belongs to r here. So 1 by y, it is also belongs to the real number, because we have the real number set, and real numbers are 1 2 and 1 by 2 1 by 3 also the real numbers, right? So if 1 by belongs to our real number, so we can say that our f is onto, right? Our f is onto. So now if suppose we change here little bit, change that our function is f such that natural number to real number, right? So now what you can say about this function is 1 1 or onto if we change here natural to real number. So this function will be 1 1 definitely, but what about the onto function? This will be the onto? No, this is not the onto, because now here we have the natural to real number, and we get our 1 by y, means we put any value of our real number. Suppose we take f 1 by 2, so when we put here f 1 by 2, so it become 1 upon 1 by 2, so it become 2. But here we say that our 1 by 2 doesn't belongs to the natural number, because x belongs to the natural number here in our domain. So in our domain we have the natural number set, and set 1 by 2 doesn't belongs to n. So in this case we say that our f is not onto. Clear? Okay, so now next come to the another example, that is f function is r to r such that fx equal to 2x square plus 3. So now check this function is 1 1 and onto. So now here we solve this. Let fx1 equal to fx2, then we put here fx1 equal to fx2. So we see here our fx1 function, what will be here, that will be 2x1 square plus 3. This is equal to, we write 2x2 square plus 3, right? So now x1 square, this will be x1 square minus x2 square, right? So this is x1 square, x2 square equal to 0. Now what is the formula of a square minus b square? So according to that, this become x1 minus x2, x2 and x1 plus x2, x1 plus x2, that is equal to 0. So now from here we can see that x1 equal to x2 if we put x1 minus x2 equal to 0, and if we put x1 plus x2 equal to 0, so it become x1 equal to minus x2. So what this condition shows here, x1 equal to x2 and x1 equal to minus x2. So this is not 1 1, right? This is not 1 1 because each element doesn't have the element to the such element. So this is not the 1 1, this is the many one function. Now come to the onto function. Let y equal to fx, and what is our fx? So our fx is here y equal to 2x square plus 3, right? So we have to convert x into term y form, so x square become y minus 3 upon 2, and our x now, that is square root of y minus 3 upon 2, right? So now here our x square root of y minus 3 and our function is real to real. Suppose our y is less than 3, y is less than 3, so what we have, if here our y is less than 3, so that x is become imaginary number, right, not the real number, right? So if our y is less than 3, so we get imaginary number, right? So we get here imaginary number, right, and imaginary number and not the real, right, not real, and our set is real, function is real to real, right? So this is not the real, so we say that this function is not onto. Clear how to check the 1 1 and onto function? So if here our x belongs to real number, but our square root of y minus 3 by 2 is not the real number, so this is not the onto function. Clear? Now next is the inverse function. So what is the inverse function? Let fx equal to 2x, we have the function, so here our function is real to real. So now this is the function fx, and this is called the f inverse. If we come to here, so this is f inverse, right? So if our fx is 2x, so what will be f inverse x? F inverse x is x by 2, f inverse x, that is x by 2. So now if we have the 4 element here in this and 8 element here, so this shows our function f4, means f4 is our 8. So what will be the f inverse? So we can say that f inverse 8 is 4. F inverse 8 is 4. So if our function from here to here, this is our function f, then this set to this set, this is our the f inverse. Clear? So next let's some more inverse functions, means like the example here. Can we define the inverse function? If in this the following functions, we can say that this has the inverse function or not. So here we have suppose this function here in the domain has a b c elements and the codomain has 1 2 3 4. So what you can say about this function can exist the inverse? No, this function has not the inverse. Why? Because this is not the onto function. Because if we talk about that, what will be the f inverse of 2? We can't calculate the inverse function of the 2, because here no 2 has not the any pre-image, right? So not allowed to find the inverse of this element 2. So for any function it must be there that function must be onto, right? Because this function is not the onto function, because here one element is there that is not has the pre-image. Next, if our function is supposed like that, here codomain are a, b, c, d and codomains are 1, 2, 3. So here we have possible the inverse function. No, because here we have two element is such that which has the two pre-images, and our inverse function is the unique function, right? So this function is not the inverse function. Why? Because this is not the 1 1. So it must be there that function will be 1 1, must be 1 1 to find the inverse. So we can say that an inverse function can only be defined on a bijection. Means if our function is 1 1 and onto, then we can find the inverse, otherwise not. So now let's take an example for this. Here we have the mapping f such that R to R, that is defined our function is ax plus b, and a, bx all belongs to the real number and a not equal to 0. So first we have to show that this is invertible, then find the inverse. So now what we do here, we have take the x1 x2 elements that is belongs to our the real number. So now first for to check the 1 1, what we do, we take fx1 equal to fx2. So now what is fx1 here? So it our fx1 is ax1 plus b, that is equal to ax2 plus b, right? So now after this here b, so now it become ax1 equal to ax2. After that a is removing here, so here this is x1 equal to x2. So now we take fx1 equal to fx2 and we show that x1 equal to x2. So we can say that our function f is 1 1, right? Our function is 1 1. So now check the onto, because for the invertible it must be 1 1 and onto. So this function is 1 1. So now check the onto condition. So for onto we have to take y belongs to r. So now we take y equal to fx, and what is this fx? This is ax plus b. So now what we do, we have to take the x in terms of y. So that will be x equal to y minus b upon a, right? Y minus b upon a. So now here we have for x equal belongs to r, there exists y minus b upon a belongs to r. It is possible because we have the real to real number set. So if our x belongs to r, so y minus b a must be belongs to r, and yes, y minus b, we have any number of y minus b upon a type that belongs to r. So this is the onto function, right? So when we show that this is onto, so now we say that this function has the inverse. So now find the inverse. So first we put here this y minus b upon a in place of x in our function fx. So fx in place of x we put here y minus b upon a. So we get here what is our function? Ax plus b. So a in place of x we put here y minus b upon a plus b, plus b. So it become what is that? Y minus b, because a cancel out here, y minus b plus b, so it become y. right? So now our function is 1 1 and on 2 we get y. So what is there exists? So we say that therefore f inverse exists, right? Therefore f inverse exists. So f inverse exists. So what is the f inverse? So here we have f y minus b equal to y. So we can say that our f inverse y, that is, what is f inverse? F inverse y, that is our y minus b upon a. So this is our f inverse, because if we have fx equal to y, then what is f inverse y is x, right? So if we have fy minus b upon a is equal to y, so our f inverse y is y minus b upon a. Clear? How to check the 1 1 on 2 and how to find the inverse? So now let's take another example. Here we have the mapping f such that R to R and defined our fx is x square. So now here you need to find the f inverse x. So what will be the f inverse x here? So we solve this. Our fx, that is given that is our fx is, what is our fx? Fx is here x square, right? So we put our y equal to fx. So now that is x square. So what is x in terms of y? X in terms of y is plus minus square root of y, right? And so what is the definition of inverse? That it must be 1 1 and 1 2, right? So but here we get that x plus minus root y, and this shows that this is not the onto. Why? Because our x belongs to the real number, right? But square root of y, it not surely that it is the real number. Why? Because if suppose real number, so we can put any value of y. So suppose we put the negative value of y. So suppose we put here y equal to root 3. So what is the square root of minus 3? So what this is, this will give our the imaginary number, right? This will give the imaginary number. So and our function is real number to real number, and we get the imaginary number. So our square root of y doesn't belongs to always the real number. So it shows that this is not the onto function. And if it is not the onto function, it means that we say that our f inverse x does not exist, right? Our onto function exists only if our function is 1 1 and onto. If our function is not 1 1 or onto, so our f inverse doesn't exist. Clear? How to show that and how to find the inverse of the function. So now thank you. Today's lecture is completed now. Be happy, be healthy, always happy.